Thank you. So as part of today's session, I would be covering the Hyperledger fabric, which is one of the most prolifically used blockchain implementation. It's being used across industries, from the banking, to the manufacturing, to supply chain, to manufacturing, supply chain, automotive, aerospace. It's being used extensively, and I would be covering what is the technical architecture of it and how do things work within the Hyperledger fabric implementation, and then a small demo, or we'll try for a hands-on. So I will start now, and I will be just sharing the slides. Give me a minute. I will share my screen. I think all of you should be able to see my screen. I have the slides running now. So just a brief on what is blockchain, so that we have a story set in place, a brief introduction on the blockchain, and then we would be looking at the fabric technical dive. So I think all of you now would be aware what is a blockchain and what is it entirely built up of, like what are the basic building blocks when you talk about the blockchain technology. When we talk about blockchain and when we talk about a blockchain implementation which would go and fit into our business world, then we need to have a business network. Then all the different entities, participants which come together to form the business network are called participants. And each of these participants would have some kind of identity and role in terms of what transactions that they can perform on the business network. Then generally, like any kind of business network, you will have some kind of exchange of something of value. And in the blockchain world, it's called the asset. Asset is what is going to change hands amongst the different participants. Then we have something called transactions. Transactions are the actual execution of the functions or methods that you've written. And these transactions will define what happens to the asset, define the life cycle of the asset, how the assets exchange their hands across different parties. And then for any transactions to occur, you will always have some contracts. Your contracts would be the conditions, the prereqs that have to be met before the transactions can go through. And then we have the ledger, which is the key blockchain part, is that where do you store all the transactions which have occurred? That is what it gets logged in your ledger. And that is your blockchain. So your blockchain, so your list of blocks which have all the transactions, that is called a ledger. So in the crux, or in a nutshell, blockchain is a shared replicated ledger. It's a distributed system where you have the ledger, which is shared across different systems. They have the same copy, and all of them will have the same updates happening at the same time. And how do you achieve that? You have a mechanism of reaching consensus to ensure that all the participants agree to it. Then it gives you the functionality or the provision of provenance, because since you're tracking all the transactions which have occurred, you know the entire life cycle of an asset, who has done what, which identity has submitted which transactions. They're getting logged in the blocks. So you have the provenance. You have the immutability. That is a very important part of any blockchain implementation, that no single entity or a group of participants should be allowed to modify the transactions which have already occurred. In case you need to modify the state of an asset, you might trigger another transaction, and then the state of the asset might get updated. But there is no way that you can go backward in time and modify a transaction content which has already happened, which is the key part, I think, which all, if you look at Bitcoin, if you look at Ethereum, all of them promise that immutability part. And that is why it is so extensively being used in businesses. And it brings in the factor of trust among the participants who don't trust, who are wary of each other. And the fact that whatever you're writing into the ledger has gone through consensus, where all the participants have agreed. Consensus, I'm just talking about a general term over here, but then when you actually are looking at a blockchain implementation, you might have different algorithms via which you can reach in consensus. So you'll have consensus. You know that you have a ledger which is immutable, So all the participants can believe it to be the final version of truth. It takes away the distrust happening between the participants who are interacting with each other in the business world. So why Hyperledger Fabric? So Hyperledger Fabric comes from the Linux Foundation called Hyperledger. And since all of you are aware of Linux is one of the biggest pillar in the IT industry, and it is one of the most extensively used platforms for developing your applications. Most of the servers run on Linux. So with blockchain being the new thing a couple of years ago, Linux Foundation got together and they have come with multiple implementations under the Hyperledger group itself. Fabric is one which has now been most extensively used and has the maximum number of participants, committers who are developing the Fabric implementation. So the key features, like all blockchain implementation, it has a shared ledger, and it has the concept of smart contract or chain code, which all of you would now already be aware of since you've been through the sessions on blockchain. Then the crux is, how do you maintain the identity? How do you track the identity? So, and how do you ensure privacy? So you have the privacy and permissioning, which gets achieved by one of the components called the membership services. And what they have tried to do in Fabric is they have tried to keep the architecture as modular as possible so that you can have different components being plugged and played. So the first version, major version, that is 1.0 of Hyperledger Fabric was released in July 2017. And IBM is one of the biggest contributor to the Fabric community. Internally, the IBM research team was working on a project on blockchain, and that is where they contributed major portion of the code for Fabric. So July 2017, we had the 1.0 release happening. Now, if you look at, we have the 2.0 release happening. And over a period of time, there have been a lot of improvements, enhancements, a lot of feedback taken from the industry who has developed solutions on blockchain. And all those things have been incorporated in 2.0. So now over to Fabric, where we look at what is the architecture of Hyperledger Fabric implementation and then the various things under it. So what I will do is maybe, how do you want to do the questions? So how have you been doing it? Will you be posting the questions on the chat window, and maybe after 50, when I have a logical break, I'll take a logical break and then we can take the questions, and then I will start my next session. So this is the architecture for Hyperledger Fabric. So you have, these are the key components I was saying, that you have your membership service, which is responsible for maintaining the identity and the roles of all the participants, a very key part of it. Then you have an ordering service, because as you would be aware, since it's a distributed system, there would be a lot of different participants pushing in transactions at the same time. How do you define the order of the transactions, whether T1 should come first or T2, T3, T4? If these transactions have been simultaneously pushed into the system, how do you arrange them in the right order? And then you have different algorithms, algorithms in terms of how do you order algorithms. So you will always have an ordering service, which is going to order your transactions and put them into a block. And then the key thing that I think all of you would be aware of when you look at Bitcoin, when you look at Ethereum, when you look at Indy, see, all of them have a component called a peer or a node, which is the component or the node. This is the component where your smart contract actually gets executed, and your ledger, where you're creating your list of blocks, gets stored. So peer is the most important component, and in most of the business network applications that get developed, each of the participants would hold a peer. And then within the peer, what they would have is, a peer can have different roles. So I will cover the two roles which a peer can play, or can be both, can be an endorser and can be committer. And then, as I was talking about blockchain implementation, a peer would have to have a ledger. Ledger is the place where you're storing the list of all transactions which have occurred. It would have the chain code or the smart contract that you would be running. And then subsequently, if you're looking at blockchain solution, cannot be complete without external systems which have to commit to it or connect to it. So you might have external systems like maybe an SAP or a customer relationship managed CRM database. You might have a lot of other systems which are already existing, which need to talk to the blockchain or might want to do some kind of maybe call a function or maybe update a database outside your blockchain. So you need to have some kind of messaging or event mechanism via which you can ensure that after having a transaction committed on the blockchain in the Hyperledger fabric, there has to be a way it talks to an external system and updates that. So that is where you need to have the events. And then when we look at, these are the components of your blockchain. But now once you have identified the components of a blockchain architecture for Fabric, how do you interact with it? So all of these blockchain implementations have an SDK, a software development toolkit, via which you can actually write client applications. Those client applications can be written in Node, can be written in Java, can be written in Go, can be written in Python. So you have multiple SDKs available via which you can actually interact with the Fabric implementation. You can write your application, use the SDK, and make calls to it. And this is a wallet which is shown here, because as I said, identity is a very important part in terms of how do you submit transactions, how do you do transactions. Identity will define your roles and responsibilities in terms of what you can do. So for any application to interact with the blockchain, it needs to have an identity certificate downloaded with it, and that is what gets stored in the wallet. So similarly, the way you have in Bitcoin, right? You have a pseudo identity and you download some certificates which say that this is, you are a valid person. You own some Bitcoins and you can actually trigger transactions or you can interact on the Bitcoin blockchain. So generally how applications interact with ledger. So I think this part of the blockchain can vary. It could be with Fabric, it could be with Ethereum, it could be with Bitcoin, it could be with Indy, it could be with Sawtooth. So the different implementations, but for most of them, the way you interact with them is usually an SDK is available. You develop your application using that SDK, and any interactions that you do onto the blockchain ledger, you always go through a smart contract or your chain code, which can be written in multiple languages. For Hyperledger Fabric, you can write a smart contract again in Java, you can write it in Node.js, and you can write it in Go. Ethereum has its own language called Solidity. So your smart contract would be written in Solidity. And if I try to do a mapping, so your client application would be your dApp that you would have written. This would be your Solidity smart contract, which would be deployed on a public Ethereum chain. And within Ethereum, you might have a list of blocks where you're storing all the transactions, and you might have an additional database to cater to or get more details of each particular asset. So as I was saying, like each of these components, when we look at the peer, which is the most important component, we have something called the ledger, where we are saying that we're storing all the transaction history which has happened as part of blocks. So now we look at what exactly is the Fabric ledger when we use the word ledger. So ledger consists of two things. One is your blockchain. That is your list of blocks which are capturing all the transactions which have occurred. The starting block will indicate the Genesis block, which will tell you like what is the kind of blockchain implementation you're using, what are the different participants in it, what are the different channels. I will cover the concept of channel later, but for now I'll say it will tell you how many channels are there. All those details about the blockchain that you have created, what is the ordering service that you're going to use, how many orders would be there. All those things would be created and stored in the first block, that is the Genesis block of the blockchain. And subsequently, you'll have the list of transactions which would be clubbed together. So maybe you can decide how many transactions you want to club together in a block. You might say that I get 10 transactions, I want to put them in one block. Or I can say that maybe I want to club all the transactions which come in 1 minute. Because if you look at the number of transactions which occur in a business use case, are a huge amount of transactions will occur. So for example, if you take a typical banking example or where you have international banking. So if I want to transfer some money to a bank in the US, what I will do is I'm going to transfer some money I will say that I have a local account in SBI. So I will say I would like to transfer this amount of money in Bank of America in the New York branch. So the number of transactions and the hops that would happen. So my transaction would actually grow from SBI to RBI, then the RBI's equivalent in the US. From the US, it will go to the Bank of America head office. From there, it will go maybe to the New York branch. So all these transactions, all these hops that are happening would be getting stored into the blockchain as transactions. So a lot of transactions, so it doesn't make sense to have one transaction per block. Because if you do that, then you can imagine the kind of blocks, the list of blockchain that would get generated would really be huge. Now, we've talked about the blockchain part, and that is what the underpinning thing of even Bitcoin. Bitcoin has all your list of blocks which are linked together. Now, what they have done is, now suppose in a typical business application, you would want to do some kind of query. So generally what happens in Bitcoin, what they've done is they always store the delta. So none of the blocks have the complete information. And what they tell you is if you need the latest information in terms of what is my account balance, my latest account balance, they would have to walk through all the transactions which have occurred through my account to calculate what is my current balance. Because all they would have stored by now is in each of my transactions would be just the delta amount that I've used for the transaction. It will never share the total transaction or total account that I have with me, amount in my account that I have with me. Now, if you come to the business side and if you want to start doing querying around it, you can imagine the amount of time you would spend walking through the linked list, right? All of you are aware, walking through a linked list is a cumbersome process. It is a tedious process. It's a long process. And if you have 10 applications wanting to query the blockchain, because we are aware that it's a single version of truth, all organizations have the same copy, all organizations might want to do different kind of querying, reporting on top of it. So what they came up with to improve the speed of query, what they have done is the latest value of, for example, if I give you the Bitcoin example, the latest or the last transaction, after the last transaction, what is the amount stored with me is what would get written into the world state, which means that it makes it faster for anybody to query on that because I have the latest information of my account rather than walking through the blocks to build and get that information. So in Hyperledger Fabric, there are two types of databases which are supported. LevelDB is the default one, and CouchDB is what can also be plugged. CouchDB is a more advanced database, so lets you write much more complex queries. And as I was saying earlier, if you relate to it, Hyperledger Fabric has gone with the modular architecture so that it gives you the flexibility to plug in databases. Okay. So before I move to the next, so it's a logical break. So I'll take the questions which have been posted onto the chat. So I have a question where they're asking about the Hyperledger smart contract language. So the Hyperledger smart contract can be written in Node, can be written in Java, can be written in Golang, all three of them. Fabric Ledger is an example of distributed ledger. That is the default implementation for any blockchain. It has to be a distributed ledger. A provenance means you keep a track of all the historical transactions which have occurred. So for example, that simple, if I have a bank account, every month I will get the account statement to see how many transactions have happened in the last 1 month on my account. So that is what provenance means, to keep track of all the historical transactions which have occurred. Hyperledger, since it's from Linux community, it is open source. So you have the code available on GitHub, you can download, you can change, you can modify things on your own and take it from there. World state is not like it's not a cache. It contains the latest state of all the assets which you're transacting on. So if you're transacting on an account like in Bitcoin, you would have the latest state of account onto latest value or the value of it on the world state. Or if you're looking at one of the example that I can give you, if I have a car and if I'm buying and if I'm selling my car, yeah, provenance can be lineage. So if I'm selling my car, so car could be an asset and its details can initially be part of the world state. And once I transfer my car or I sell my car to you or maybe to Mayank sir, then now the car's owner would get changed to Mayank sir and that would get stored. So the world state would have that the car's last ownership is with Mayank sir, but the transaction would say that the original owner was me and then it got transferred to Mayank sir. So the transaction would get stored in your transaction log, but the latest owner of the car would say that it's with Mayank. So Bitcoin is not legal in India right now. Mutable ledger is like your any database that you have. So wherever anybody can go and modify it. So that is a mutable database. Mutable ledger would be which can be modified easily. So how many? Okay, so how much time needed for a transaction? So lot depends on what is the amount of data that you're writing. What I've seen, they've done experiments, they've seen TPS of around 2000. A lot depends on what is the size of data and how many peers are there and how complicated is your smart contract that you have written. Next, I have a question. Yes, it might be useful for real estate and registration departments. So blockchain would very well fit in terms of any kind of government departments, because as we know, there are too many systems which talk to each other. To have it in one system which can be recognized as the final version of truth, it would be good. So the number of transactions, what we have done is that we've left, it's a configurable thing in Hyperledger Fabric where you can decide that I want maybe 10 transactions to go in a block. You can say, you can define the number or you can define the time. So it can be you can either go with the number of transactions to go in a block or you can say the time. So if you say that if you're going to get a lot of transactions in a short period of time, you can say that maybe if I receive whatever transactions I receive in 30 seconds, I will put it into a block. Or if I have transactions which are really staggered around, then I can say maybe once I get 10 transactions, that's when I will commit it. So there is no concept of currency in the Fabric, unlike others. So there's no concept called Ether or Bitcoin. It is all on you. How do you want to create your asset and how do you want to transact on them? So blockchain, yes, it works on Windows. You have to go on Windows 10. And Hyperledger is not a public blockchain like Ethereum or Bitcoin. So if you're building up an application on Hyperledger Fabric Ledger, you would have to bring up a network with all the participants. They would bring in their own nodes. It's a private permission blockchain. So it is not open for everyone. Though you can do it on your own. Maybe when you're developing applications on your own, you can just download an instance of Fabric and bring up your own network, but it is a private permission network. So only people who have the identity, the relevant identity, only then they can do it. It works on Mac also, and Genesis is the first block which has all the details. So the difference in then I have one question on how does who validates and who commits the transactions. We'll cover that later. And I have, I think, one more question in terms of mining. There's no concept of mining in this. So we have come up with a different consensus mechanism, which I will cover. So it is endorse, validate, and commit. I would be going through in the subsequent sessions. Okay. So I'll take a pause on all the questions, and I think I will go ahead and we'll cover deep dive. And I think some of the questions would get addressed when we cover the more details. So as I was saying that we have different, I said, right, we have a key entity in a blockchain network, which is called the node, which is the most important part. This is the place where your ledger is going to be there, where your smart contract would be there. And then these node or peer. So I will be using the word node or peer interchangeably. So they have different roles. So a role of that node or peer could be that anyways, they would be committing the transactions because it's a shared replicated ledger. All the members, all the nodes in the network have a copy of the ledger. So committing would happen. But what they have done is they have come up with a new concept of consensus, which is endorse, validate, and commit. So the nodes could play a role. I will elaborate on what endorse, validate, and commit means. But what they have done is like those who are aware of Bitcoin, you know how much effort is spent in mining, how much time is spent in mining. And what they say is you take 10 minutes to actually generate a block, because the mining problem that they give you takes 10 minutes to generate the final block. It could be lesser also, but yes, it takes roughly on an average 10 minutes to generate a block. And what they say is that you need to have 6 blocks generated in a row before they actually accept that new links which have been created. So which means that you actually have to wait for an hour to validate the new linked list that has been created. Now, in any real life transactions or banking transactions, if you see, or a supply chain or any booking transactions, can you imagine a bank waiting for 10 minutes for a transaction to go through? You cannot. So if a bank has to transfer some money from your account where you have given all the permission, or another example where you're saying that you have your government registry or maybe a land registry, you cannot say that you're going to wait for 10 minutes for a transaction to commit through. Just a simple transaction where I want to change the ownership of my land which I'm selling and my answer is buying. So you cannot wait for 10 minutes. So what they have done is they have tried to split the consensus mechanism in a way that it speeds up in a real life business example. And that's what they've done as part of endorsement, validate, and commit. What they've done is instead of all mining nodes running, you're trying to solve the problem and then generating the block, they've handpicked few nodes to say that these are the nodes only who will actually execute the smart contract. So that is what it means by endorsement, that these are my set of nodes from these organizations who are actually going to execute the smart contract. And if the result, which would be same from all these nodes, if this is correct, then the transaction can actually be committed or a block can be generated. So that is what endorsement did. I will cover it in more details and you'll get much more clarity after that. And then, as I said, you have an ordering service because you have a lot of participants who are going to keep pushing transactions from different applications, but since they're using the same blockchain, so there has to be a way, how do you order the transactions in which they occur? So the ordering node are just going to receive the transactions, put them in a block and cut the block and send that block to be committed as a part of the blockchain. And then we have something called the certificate authority. This is the authority which is actually going to generate or issue the digital certificates to all the different participants of a blockchain network. And each of these participants will use these certificates to perform their roles and to validate their identity. So as I was saying, so the consensus mechanism for Hyperledger Fabric has been split into endorse, order, and validate. Endorse means that you identify a set of participants who will only execute your smart contract. And then you have another entity which is called ordering. As I said, you have an ordering service which is actually going to order your transactions which have been received and cut a block. And before committing or before actually writing into a peer, it is actually going to validate whether the transaction that you have to commit, whether the input set and the output set the input set is in accordance with the ledger data that is available. If yes, it's going to commit it. So generally, if you look at what mining does, mining in this case is the functionality of endorsing, order, or validate, or instead of endorsing, I can say mining. All these things are done by one peer itself. So if one peer is doing all these three things, it's going to take much longer time. So first, it's going to solve a problem. Then after solving the problem, it's going to order the transactions it has received. After ordering the transactions, it is going to validate whether all the transactions are proper or not, and then do a commit. So what they did in the business blockchain implementation, they have decided to split these three things. So you have a set of nodes which is going to do only endorsement. You have a set of nodes which are only doing ordering. And then you have a set of nodes which are mostly all the nodes which are going to do the validation before writing into your ledger. So this kind of brings in concurrency. It kind of distributes the load on one peer and it improves the transactions per second. And that is the key reason why they had to come up with better consensus mechanism in terms of blockchain, which can be used, which satisfies the requirements of businesses. So this is how it happens. So this is a typical transaction flow which occurs. So as I said, you will always have a client application, which would be your end application source. As you would have read about Truffle, where you would have created your own dApp. So this would be an equivalent to dApp. So my client application is my dApp. SDK is, I think they have some libraries also in Ethereum where the libraries which you use actually to connect to the Ethereum node and trigger your smart contracts and get outputs, all those things. So you'll always have an SDK. Hyperledger Fabric has its SDK. As I said, it's in Node, Java, Python, and it's in Golang. So these are the 4 languages your SDK is available. The only thing you have to remember is Fabric is open source. So a lot of times there is a delay in terms of when the Fabric version comes out, when the SDK is available. But generally the community is quite vibrant and they keep things up to date. So this is how it would look like. So if I'm saying that, as I said, like the key component of a blockchain Hyperledger network is you have something called the peers or the nodes. So I have these 5 peers and 5 peers, out of which I have clarified, I am saying that only 3 are the ones which are actually going to execute my smart contract, which means these 3 peers become my endorsing node. So E0, E1, E2 are what I am denoting as my endorsing peers. And these are the peers which will have my smart contract sitting on them. So I can define my endorsement policy. That is the word that we use in the Fabric world, Hyperledger Fabric world, saying that how do I define my consensus? I will define an endorsement policy. I will say that E0, E1, E2 are the ones who sign. When I say that these are the ones who sign, I mean to say that these are the ones who are actually going to execute my smart contract and sign their digital identity saying that this is my certificate, I am E0, and I have signed, I have executed this transaction. So when you write the application, you're actually going to send your transactions only to these 3 nodes, which are my endorsement nodes who are going to execute the transaction. So if you look at how these are, so you have the blue, E0, E1 are my endorsing nodes. My P3 and P4 are my committing peers. And these are, as I said, my endorsing service. We're going to be ordering the nodes, and then eventually the nodes are going, the blocks are going to be committed. And then I have my smart contract in E0, E1, E2, and P3 and P4. I have my smart contract A at P3 also, but I'm saying that I would rather use E0 for endorsing and not P3 right now. So now, as I said, when I said endorsement means executing of my smart contract. So that is what is going to happen here as step 2. I'll have my E0, E1, E2, which are going to execute the transactions which the client has submitted earlier. So it is just an execution right now. There's no update to the ledger happening. What it will do is, as we know that each of these nodes have their ledger. So you have your read set and you have your write set. So for example, if eventually I'm going to, as I was giving you the example that I'm going to change the owner of the car from Ruchika to Mayank. So what it will do is, if I'm sending that transaction, it is going to check that the original owner is Ruchika, that would be my read set, and the new owner is Mayank, that would be my write set. So it is going to generate the read set, which is the original owner value, which it will pick up from the ledger, and it will say this is going to be my write set, so this is the value that I have to update as part of the transaction. So each of E0, E1, and E2 will execute and generate the read-write sets and say that these are the peers who have actually executed. So that is what is meant by transactions can be signed and encrypted. It would be signed by the executor or the endorser's identity. And if you don't want anybody to sniff, you can actually encrypt the read-write set so that no network sniffing can happen. So after your transactions have been executed, right now not committed, so the transactions have been executed, the read-write sets have been generated, and the read-write sets are signed by each of the peer identity. The response actually goes back to the client application. Now it is up to the client application to validate whether all the responses match or not, whether all the endorsement peers are giving the same read-write set. Even if the application code does not do it, internally the blockchain will do it. So the only thing is you can save time. So if you can validate here, if the client is application, you validate whether you have received the same responses from all of them. Yes, then you know that that transaction can be committed. In case you find out that the read-write set are not same, then you know that there's been something which has been compromised, and you can stop it there itself. You can actually identify which node has gone bad or which node has been corrupted if the read-write set stands out of that one. As I said, this would later be checked, but it is good. You can save unnecessary time which would get caught during the validate phase. As I said, consensus is endorsement, ordering, and validating. So if you can catch a problem at endorsing, you're saving time from it to be caught in the validate state. Then once your transaction has come, you have validated whether all the read-write set are correct from the endorsement responses. Now the client application can push it for ordering. So it will send an ordering request. And as I said, there would be multiple applications accessing that ordering request, because you'll have different applications of different participants running. So maybe you have an application running for SBI Bank, you'll have an application running for RBI Bank, you might have an application running for maybe Punjab National Bank. All of these banks would be running applications on the same blockchain network. So they would be pushing transactions at the same time, which would go and hit the ordering service and would try to execute them. Not execute them, sorry, order them and try to cut a block and then put it into the blockchain. So once the ordering service receives all the transactions, and based on the criteria that you have defined to say that you're going to either say that I want 10 transactions and cut a block, or I will cut a block if I have received 10 transactions in 1 minute. Accordingly, a block would be cut, and that ordering service is going to send that block of transactions to all the peers now. So that is what is denoted here. It's going to do a broadcast in your distributed system. You have a cut block, you send it across to all the peers who are now going to commit it. So now this is the step where actually they're going to validate the read-write set. So now all of these the blocks have been received. What it will do is it will read the first transaction from the block, take the read-write set, see if the reads matches the existing data in the database. If it matches, it will put in the write set. So that's what it will do. That's how it will validate. It will read whatever is the read should match the database. If it does not match, it will reject the transaction. If it matches, it will commit. So that is how the validation happens during the commit phase. So, and for example, so if you look at the last, so when you say invalid transactions, so what might happen is that you have received multiple transactions acting on the same asset. So if I have, as I said, if I'm transferring the ownership of the car, and if I have received a spurious transaction to say that from Ruchika, it gets transferred to Mayank, and then I get another transaction says with Ruchika, it gets transferred to Avinash. So if Ruchika transfer to Mayank comes in first, what it will do is the read set for the first transaction will say Ruchika and Mayank. And it is going to update the database saying that the new owner of the car is Mayank. Now, when the next transaction comes, which says that the read set is Ruchika and the write set has to be Avinash, it's actually going to check whether Ruchika is matching with my existing value in the database, which it is not going to match because already the owner has been changed to Mayank. So it is going to reject the second transaction. So that is how the transactions might get rejected. So what you have to do is, so in this case, it could be incorrect transactions, but there could be situations that it is a valid transaction. So for example, it is an account information, my bank account information, my bank account balance. And if I have done multiple transactions of my account, one after the other, so the chances of the second one getting rejected is quite possible because the balance amount might change from the first to the second one. So once, as I said, the transactions have been validated on each of the peers, they're all going to commit. And then you can program your application in a way that you get the notification back to say that your transaction has been committed to all the peers. So in that way, you know that your transaction has completed the full cycle of endorsement. It got ordered and then it got validated before it got committed. And in case, as I said, that if you have any external application that you want to update. So for example, as I gave you saying that my account information is getting updated. And once my account gets updated onto the blockchain, I want an alert to come on my mobile phone. So what I can say is that the application which is going to actually send an alert on my mobile phone also has to be alerted saying that the transaction is committed. The trigger point can be used to send a message to my phone. So now I think it's another logical break, and I will go through the list of questions before I move to the next part. Said we're looking at the ordering service, and as I've told you, the role of ordering service is to order the transactions which I've received, put it into a block and send it across. Now it happens via a concept called channels, which will get covered in the next thing. So you always have to ensure that ordering service is one of the most important service, because if your transactions don't get clubbed into a block, you won't get blocked, and eventually your blockchain will not work or will not get created. So the service that you have to create as part of the ordering service has to be crash fault tolerant. So we have something called the Raft consensus. So we have Raft, we have Kafka, we have Solo. There are 3 consensus mechanisms available via which you can ensure the ordering happens. So Raft will ensure crash fault tolerant. It says that you need to have 3 nodes as minimum, and it always says that you should have odd number of nodes. So Raft is, I think, an open source consensus mechanism which gets used extensively in your containers. So if you look at etcd, is the Raft implements the Raft ordering service to maintain the status across states across your distributed database, distributed systems, not databases, distributed systems. So Raft is a completely topic on its own. So if you want, you can read about it. You'll get a lot of information. So if folks were aware of Kubernetes and how containers are managed and how do they manage it, Raft is the mechanism that they use to ensure the status of all the containers and how they share information. So as I said, channels. So when we talk about blockchain network, now if it is one single network, so everybody can see what is happening. Now, if you want to bring some kind of privacy, so for example, I gave you earlier, you have Amazon working with multiple suppliers. So if Amazon puts up a blockchain system, it can, all suppliers come out of it. Now, all these suppliers would not want to share their information with other suppliers because there's be a lot of confidential conflicting information. Amazon might have different contractual agreement with supplier 1, different with supplier 2, different with supplier 3. Now, since the suppliers don't trust each other, what feedback was given from the industry, and it came in blockchain later, was that there's a concept of channels. So channels can be defined as subnets. So you have one big network where all the participants are there, all of them can interact with each other, see what data is being exchanged. And then you have a concept of subnets where you restrict the number of participants, saying that I have this channel where I will say that I have only 2 participants, and their data, the interaction between these 2 participants would be limited to this channel. So to extend that further, for example, if I say E0 and E1, so I have red, which is one channel, and black, which is another channel. So now what they have done is once they bought in the concept of channel, they have limited the scope of ledgers also to a channel. So each channel will have its own ledger, which means that each channel will have its own list of blocks and have its own world state. So now, if you go back here to this one, right? So now what will happen is each ledger would be part of one channel. That channel which will have its own chain code, and then all the chain and the events associated with that channel would be associated with the chain code which is specific to a channel. So now what exactly is a chain code? We've been talking about it all this time. So chain code is actually a function or a program which runs. So how does it run? It can run as a process on your machine, or it runs as a Docker container. So when you are running any of those blocks, if you try to run any of those Hyperledger Fabric samples, you would always see chain code running as a different Docker container. And that is where your transactions are going to be run or executed. So now to run this, you have to have your chain code to be installed on the peers, because you're going to install it on the peers which are actually going to be your endorsing peers. As I said, like chain code is run, or your smart contract are only executed by your endorsing peers. So your chain code has to be installed on those endorsing peers. Installing means just uploading the runtime binary, and instantiating is actually running a process after it. So you will have a container which would be running. Now, the other thing what can happen is, the way it has been written is that one peer can be part of multiple channels, as I have indicated here, as it's indicated here. E0 can be part of two channels or 3 channels, or it can be part of 1 channel. So what happens is now, once the moment you get channels, the concept of channels and each channel is having their own ledgers, you can have concurrent execution. So that is another way of increasing the speed of transactions. Now, if you look at Bitcoin, I think they just have one public blockchain. So there's no concept of privacy over there. If all the nodes will have the entire blockchain sitting, it's just that you can restrict it by encryption, decryption in terms of who can access it, but everybody has access to all the data. With channels, you're actually restricting the access of data to entities with whom you don't want to share it. So typically a single channel network would look like this. So I have indicated the blue line over here, or the blue blocks is blockchain. It is 1 channel. So I have just 1 channel. I have 4 endorsing peers in it, and I have 2 smart contracts sitting on them, and I have 1 endorsement policy. Now, similarly, if I have a multi-channel network, I will say that I have my E0, which is part of red channel, which has smart contract YZ. I have E1 and E2, which are part of different blue channel, which have a different smart contract A and B. And then I have E3, which is part of both the channels, blue and red, and has the smart contracts A, B, and YZ. So any questions? Or I think I'll go ahead for now. This was a small section, components, and maybe after the components, I'll take a logical break, and then we can have questions. Peer node. So this is the individual entity that you would see when you bring up a blockchain network. So when you bring up a blockchain network, you're going to see a lot of Docker containers running, which I will show you after this. So peer would be the one which is the entity which will have all the details required to be a part of a blockchain implementation or network. So a peer could be part of multiple channels. So if it's part of 3 channels, I've shown different colors, red, green, blue. So based on the different channels, red, green, blue, you will have different ledgers, red, green, blue. Each ledger will have its own blockchain and world state. And then you will have different chain codes. And those chain codes are going to be installed as part of a particular channel. They would be installed, and then you will instantiate it. And each of these peers will have something called membership services. As I said, that identity, since blockchain Hyperledger implementation is a permission private network, the identity of every component which is doing any kind of transaction, any kind of work in the network has to be tracked, has to be known. So that is what the MSP is going to do. So for example, as I said, application which is actually submitting a transaction will have an identity which would be stored in the MSP. The endorsing peer, which is actually executing the smart contract, signing the smart contract, generating the read-write set, which would have its own identity. Then your ordering peer would have its own identity, which is cutting the block, which will say that, yes, I'm a valid ordering peer, ordering node, I have cut a block, and this is my identity. So all those identities of the network and participants, network components have to be stored, and they're stored in a membership service provider. It's actually a directory. So if I look at peer could be a virtual machine where you're running a Docker. It runs as a Docker container, and once you log in into that peer, you would see a directory called MSP where you'll have all these certificates stored of all the different participant components of a blockchain network. And the last is, as I said, that if you want integration with systems which are outside the blockchain, for example, like as I said, if I want to commit a transaction, if I execute some transaction on my banking account balance, and I want an SMS to go, I would say that once the commit happens, I'm going to send an outbound event to say that I have committed onto the blockchain. And I would have an application which will be listening to that event and say that, yes, committed. I will send an SMS or I will send an email to the clients. So client application, as I said, you have client can be written in these 4 languages, and you have the SDKs, and a lot of sample code is anyways available in terms of how do you write your client application, then how do you connect to different channels, how do you receive events, how to create your MSPs, how do you store the digital identities which you would be using to interact with the blockchain. Fabric CA, as I said, is the most, when you talk about identity, it's the Fabric CA, which is actually going to be issuing all the certificates. These are your typical certificates which would get issued. And along with that, as I said, Hyperledger Fabric implementation is a modular and gives you a lot of pluggability. So you can ensure that you need to ensure that Fabric CA is always available, because any new entrant, any new identity, any new participant, any new user which wants to register on and start using the blockchain network would connect, would talk to the CA, get a certificate, and then start using it. For high availability, there's a database available, part of the Fabric CA, where all your certificates are stored. Then application, a production grade application, you might want to connect to an LDAP, a company's LDAP for the users, identity authentication, verification. Then you have there's a hardware support for how do you want to store the certificates so that nobody can steal them. You have the that is an HSM. It's called HSM, hardware security module. And then if you have a lot of participants, a lot of members who are going to be interacting on the blockchain, you might say that I might have a central root certificate authority who's issuing the certificates. And then I can have intermediary certificate authorities. I don't have one central authority, but I have multiple authorities which might be associated with different organizations, different participants, to reduce the load. So I will take a pause here, and then I will take a question. I will show you how do you actually set up. So these are the steps in terms of how do you actually create a blockchain network. So while I talk, I will. So I think we had shared the steps with all of you in terms of that you can actually, we had shared a VM with you to set up, because Windows, you need Windows 10 and you need Docker to run on Windows 10. But if you don't have it, and if you have Linux, or if you have Mac, then it is much simpler to run it. So I had I have downloaded the Fabric samples which are available. So it's a public GitHub link where you can download the Fabric samples. And this has a lot of examples in terms of what you can do to run the blockchain network. The first thing that I need to do is I don't have my Docker running. So Hyperledger Fabric implementations relies on Docker to run all these containers. So first I need to run my Docker. It started running. Isn't my Docker running? Ah, it is running, it's coming up. So the Docker is the first thing that should come up for me. And while I'll go back, while Docker is coming up, I'll go back to the presentation. So the first thing when you are actually bringing up your network locally, so these are commands which are available. And now we anyways have scripts on how to bring up a network. So first thing is the scripts will actually bring up an ordering service. Then you can actually bring up all the nodes that you're going to have. So when you bring up the nodes, at that point of time, you are not going to say which is the endorsing. You can specify in the configuration which would be an endorsing node. You can specify those. Then you can say that I'm going to install my Chaincode or create on those nodes. Then I'm going to actually create those channels. As I said, like you can have multiple channels. Then you will have your nodes connecting to those channels. That's what has happened here. And then once you instantiate, so you start instantiating the Chaincode onto the channels. And then when you're instantiating the Chaincode, you can define what would be the endorsement policy for those channels. So now if I go back here, my Docker is running and I will go to my FabCar sample. So in the FabCar, is the screen size okay, or do you want me to change the colors? Okay, I'll just make it. Okay. So to start with, I will just say .start fabric. The same thing you can do with the Ubuntu image that I have shared. I think it already has the fabric sample downloaded. You just have to do .start fabric on it. And it's going to do things. So since I had already set up this network, now it's trying to set up those network again. As I said, it has to create my ordering service. It has to create my certificate authority. It is creating all my peers and nodes. All those things are getting created. After creating the nodes over here, you can see that it has created the channel. Then it's going to ask the channels to get joined, the peers to join the channel. And then they join the channel. They're still joining. So I had multiple peers created. So all those peers are joining the channel. Then they have now actually installed my Chaincode. The smart contract, if you look at here, it has installed my smart contract on it. So this generally takes time. So while this is happening, I'll just show you the command which I have run. So Start Fabric has the complete script in terms of how do you simply bring up a network. So initially it is doing some kind of cleanup, and subsequently there are a lot of parameters that you need to set for your network to come up completely. So these are the steps where it has given that you need to install the smart contract, you need to install the smart contract in all the different peers. You're looking at how do you instantiate it. Then how do you submit a transaction over here to say that yes, your network is up and running. So the important files when you look at in bringing up your network is over here. So as I said, when you're bringing up your network, how do you define your network? What would your network look like? So there are files available where you are going to define. So there's something called Docker compose file. So as I said, all the containers, Hyperledger Fabric is implemented, relies on the Docker implementation, and all the different entities which get created for the Fabric are Docker containers only. So if I go back here, I think all my containers have been created. So I'll show you how it looks. So these are the containers which have been created. So if I go back, I'll have not containers have been created. I'll have a container which will talk about what are my peers running, then what are my different database that I need which is running, what are my certificate authority which is running. So if I go back here, Kytomatic is UI based where you can see what containers are running. It's easier to show, that's why I've just opened this for you. So you can actually see that I have one orderer running, I have one peer running. So how many peers have I running? I have peer 0 org1, I have peer 1 org1, peer 1 org2. So what it has created, it has created a network which has 2 organizations. Each organization has 2 peers in it, and each of the organization has its own certificate authority. And then I have my orderer. And for CouchDB, it has generated so many, it is ensuring HF for me so that there's no problem in terms of where my data is going to be stored. Orderer, it has created only one instance. The moment you go with the development environment, this is a environment, so it has created only one orderer. So it's going to be any transaction comes in, first out. There's no ordering which is going to happen. It's going to be a first in, first out. But when you talk about your Raft or when you talk about your Kafka, then there's going to be more, you'll see many more number of orderers who are actually going to order your transactions. So this is a minimal network or that you can create and test it on your system. I'll just bring this down. So the only reason I use Kytomatic was this screen looks this screen looks cluttered. It's easier to show you over there. So what this has done is it has created a network for you and it has installed a chain code for you. The chain code looks like this, which has got installed. So by default, it has installed this chain code. So in this chain code, I have created this chain code. What it does, the asset is a car, and we keep performing transactions where we will modify any of these values. We already modify the make, model, color, owner. And this is how a smart contract looks like. She will cover in more detail tomorrow in terms of what is a smart contract, how exactly do you deploy it on a network, and how do you write an application via which you can invoke a smart contract. So any folks from programming background, smart contract is any function that you write. And the entry point, like in Java or C, the entry point is usually main, right? So similarly, in a smart contract, the entry point is invoke. So anything that you want to execute will go via invoke. And then you can send a function name that you want to perform, and you send the parameters, some input parameters you're going to send. And based on that, the function would be executed. Then you would actually go and write into the blockchain. And then the response would be your return parameters, which would come back to your application. So I'll just show you how to run it. So go back to my fab card. So over here we have sample code in terms of always the first step is how do you enroll? Enroll is that you download the certificate. So as I said, that any kind of transactions that you want to do onto the blockchain, you need to have your certificates with you. So enrollment is the word, enrollment or enroll is the word that we use where you talk to the blockchain network for the first time to get your certificates downloaded. And once you have your certificates downloaded, you can perform anything after that. So enrollment is done as part of this. Then invoke is where what they're doing is like invoking a transaction where you want to actually execute a smart contract. Query is where you're actually doing any kind of query, where you're not executing or not writing into the database, but you're actually querying what is sitting into your world state database. So I will leave this as of now. And then, so as I said, this is how a network would look. These are the functions that you can do. And this is something that you can test on your own if you have the screen, if you were able to set up the Unix. So how many of you were able to set up that environment, the Unix environment? Did anybody do that? Okay. So whoever has done that can actually go to that FabCar directory. You would see it in the home. I think it's on home, user home, and there, that's where you see your fabric samples. And in the fabric samples, you can go to FabCar. You can go to FabCar, and in the FabCar, before that, I think since it's a Unix thing, the Docker is already running. So you just need to do a .start, and your network is going to come up. And then you can do a Docker ps -a to see all the running, all the Docker containers that have been created. Okay. And in case there are multiple network scripts available. FabCar is one of them. And you can look at, you can try maybe balance transfer, you can try basic network, commercial paper, first network. So these are all these sample codes that are available for you. So if I go to first network, I think gets covered as part of basic FabCar, but over here, it'll create a different kind of network for you. So you can experiment with these and see how your networks get created. Go through these Docker files, the Docker compose files, which define the definition of your network. So for example, if I show you one of the compose file, how do you define the network? So the key, one of the file is your config.tx.yml. This is where you would define your network. So it's a YML file. You will say that these are going to be my, this is going to be my orderer. This is the name of the orderer. This is where I'm going to be storing all my certificates for that orderer, where I set the membership service. And then for all of them, they have different policies which you can define. Then who would be my different participants, who would be part of it. Participants or organization is a logical entity, and within that organizations, I'm going to have peers where it's going to be running. So you can actually go through this when you have your setup or whenever you're able to set up, or you can actually download the fabric samples to just go through this. Windows, if you are going to just run the basic functions from here, I think the Docker toolbox should help you. You should be able to do it. But for Shikha's thing, where you're going to run IBM blockchain plugin on Visual Studio, you need the Docker thing. So if you're running outside the Visual Studio code, your Docker toolbox should be enough to actually create a network on Windows. But Windows has a lot of other issues. You might hit issues in terms of something on the node, and you might need the Visual Studio build tools. So preferably, if you have access to Linux box, I would say that you use that. Or on Windows, if you can download the Oracle VirtualBox and download an Ubuntu image on top of it and then play around with it. I would recommend using Ubuntu on Oracle VirtualBox and then run that, or Fusion, any of those things. VMware Fusion, you can run that. That would be more easier to play around with all these things. So whenever you define a network, you always go through this config.tx where you define your entire thing, and then you define your certificates and the different names and what would be the rows you would define here. So these are the two key files you use to define your network. And these are the files which would undergo a change. And then we have our Docker compose file. This is the language. This is specified by the Docker. So you might have to go read the Docker details about how to write a Docker compose file in the Docker website. It will tell you how to do it. There's a specific format in terms of any process that is running is called a service. What should be the name of that service? All those things you can define. what should be the port on which it should listen, and what are the different environment variables that you want to define as part of it, or what are the different volumes. Volumes are your mount points that you want to say. So since it's going to run within your machine, so you have your local directory, and what does it map to a directory within the container that is running. So all those things you'll have to define. So this is the place you can look at it. I know this is too much of information right now, but you just need to have an idea where to look for what. So that's the only reason I have covered this. So it's okay if you don't understand. It's just to give you an idea. When you start exploring Hyperledger Fabric, when you start looking at building a network on your own, these are the files that you need to look at. These are the files that you would have to modify, change if you want to change any name, because everywhere it's possible that maybe that port is blocked or you cannot use those ports. So this is the place where you're actually going to define which port to use, what are the names that you would use. Or if over here it's capital, maybe you want to put a specific name instead of org1. So all those things this is the place that you would define. So I'll move back to my presentation. So we were we're looking at the endorsement policies. So as I said, endorsement is one of the part of the consensus process that has been implemented in the Hyperledger Fabric. And it is actually the part which is actually going to execute your smart contract. So whenever you deploy a chain code, you will always define saying that which peers are supposed to execute that smart contracts. So internally, the way it has been implemented is that there are two smart contracts, which we call the system chain code. So any kind of execution that you want to do within the Hyperledger implementation, we call it as system chain code. System chain code is something which blockchain or the Hyperledger Fabric is going to do for its own requirements. And your smart contract is what you're going to do as part of your application code. So as I said, you have something called the endorsement system chain code. So whenever you send an endorsement request, which is actually going to validate or execute your smart contract, create your read-write set, then sign it. So that part is actually done by endorsement system chain code. And after you have created your proposal, as I was saying, right, your read-write set, you've signed the transaction, it goes back to the client application. The client application collates all those responses. Then it sends it to the orderer. After the orderer receives it, it would receive a lot of transactions. It would put them in a block. And after putting them into the block, it sends it to the peer. And I said, after the ordering, so you have endorse, you have order. The third thing was validate. So the chain code within the Hyperledger implementation, which does the validation, is called the VSCC, the validation system chain code. And it is actually going to go through all the transactions which are part of the block, validate all the signatures, validate the read-write set. And once all those things have been validated, it's actually going to write the block into the ledger and update the world state database. So the fact that there's something called ESCC and VSCC, again, these two are pluggable components. So in case you want to do something additional, something you want to modify, it is up to you. You can go and change it. By default, this is what the Fabric implementation would give you. But if it's something you want to modify in terms of maybe you don't want to validate because you think that it's not needed, then maybe you can write your own implementation of a validation system chain code where you don't do any validation. Or you can decide that maybe I will not commit in all. So it's left to you in terms of how do you want to do it. The only thing is, since you're modifying the source code, you'll have to rebuild the source code and then use that source code to actually install the Fabric. So those additional steps you'll have to do. So these are how do you define the endorsement policy, the syntax. So you can either do it via command line. So if you're not using any tool, so the only way for you is using a command line where you can say that this is my chain code. I would like to instantiate it on this channel. this is the name, this is the version, and which is the name of my chain code file, and then my input parameter, which function I want to pass when my chain code gets instantiated, and then what are the different parameters I'm passing to it, and what would be my endorsement policy. So when I say, if you look at my endorsement policy says that or1 msp.member, what I'm saying is any peer or node who is part of the organization one is the one who's going to execute it. So as I said, that because of high availability, and you always have to ensure that you give any peer as a part of an organization who can actually be the endorsement peer. Never pinpoint to a specific peer, because the moment you pinpoint to a specific peer, if that peer goes down, your endorsements are going to fail, and your endorsements will fail, and then your transactions will not get committed. So you always have to keep in mind that for every key peer, whether it's an ordering peer or whether it's especially for endorsement peer, you always have to have backups. So these are some examples where you can say that I need these three peers. The first one where it says org1 member, org2 member, org3 member. I want my execution to be done by the peers belonging to org1, org2, org3. All of them should execute it. All of them should sign it. Second one is an or, where you can say that maybe either or1 or or2. Whoever responds first for my endorsement, I'm ready to go ahead with that. Or you can have a combination of or and and. Both of them work fine. So membership service, as I said, that everything in blockchain anywhere is driven by identity of the user who's actually going to transact on it, identity of the different components on it. So organization is who defines who are part of your blockchain network, Fabric blockchain network, because as I said, Fabric blockchain network is a permissioned and private. Private is, and you can only select a set of participants who can be part of the network. It's not a public like Bitcoin where anybody can join, or like Ethereum where you just need to download some, I think MetaFlask or something you can download, and then you can connect to the Ethereum blockchain, which is already running. No, nothing like that in blockchain Fabric. You have to create your own network, and then you have to invite who are the participants to it, and then give them different permissions as to what they can do. So as I said, like when I talk about organizations, these could be, if you're looking at a consortium of banks, if you're looking at a network of banks, it could be SBI, could be one organization who would say that I would be distributing all these identities. And within my bank, I will have different roles and different components as part of the network. So I would have someone who's the admin of the network. But admin will have certain roles in terms of if the admin will only be allowed to go and update the chain code or modify the chain code or instantiate the chain code. Not everybody, a user cannot go and update the chain code. So if I am the application user, I've written an application and I'm sending a transaction, I will not be given the authority or permissions to actually go and change the chain code. I would just be given the permission to invoke a chain code. So that's how you would define different roles in terms of what each user can do. So you'll have an admin who will be responsible for ensuring that your chain code gets installed, instantiated, your channels get created, people get, the different entities get invited to that channel. Then you'll have users. Users would be who are actually using your application that you've written. So I would be a user. So if SBI has a blockchain application, then I would be a user who would be using that. But it would be the identity of SBI, which would actually be committing onto the blockchain. Peers would have their identity, as I said, because you have peers which are defined as endorsing peers. So when a transaction has to be committed, it will always check whether the endorsement was done. So you have the signature, or you are storing the certificate at the identity of the endorsing peer. Same way with orderer. As I said, you have that validation system chain code, right? So before committing, it would always check whether that block that has been generated by the right orderer. So there are no fraudulent ordering nodes which have come onto the network and who are cutting wrong blocks and then sending it to you. So that way a network will have many organizations, which we call it as a consortium, and each organization will have its own ID. So generally this is how it would look. This is an example. So you have in here I have 2 organizations. I have org1, org2, and then have the third one, org3. So in org1, if I look at, I have created 2 nodes, and E and E. I have 2 endorsement nodes which are part of different channels, and they have different smart contracts. But I can have the same CA, because CA is associated with an organization and not with the nodes. And then I might have another organization, which is org2, which is just running the ordering service for me. They would have their own CA, because each of these ordering nodes would have their own identity and certificates would be there for each of them. Then I would have an org3 where again I might have 2 nodes, and which these 2 nodes are part of different channels. So generally this is how the network that got created was something like this. But I think the sample, you have only 1 channel, but yes, you can modify those configuration files to get 2 channels, and that is what will update your Genesis block. So membership service provider, one thing you always have to keep in mind is that please do not lose the certificates. So that is why once the identities or the certificates that you download to run for your application, to run the application, to perform transactions, you have to ensure that you don't lose them. And that is why for a production grade, it is recommended that you use that SHM, the high security module, to ensure that your certificates don't get stolen. Because once your certificates get stolen, then anybody, whoever uses that identity, uses that certificate, can actually execute the transactions and can actually query transactions. Not much about executing, but with that identity, it can query those transactions, run query transactions, and access the data. So what they have done, again, you cannot go to the Fabric CA every time to validate the identity of the different components. So what happens is that each of the different entities which are there as part of blockchain network. So you have your client application, you have your peer, you have your ordering service. All of them will generally have a directory. When I mean a wallet, it could be a file directory that you create, or you can say that I create an HSM, high security module, which is provided by the hardware. Or maybe I would have a database connection where I will store all my certificates. And for every transaction, if I do, for example, when the client actually wants to invoke a transaction, it is going to give the certificate from here and send it. When the endorsing happens, it's going to, so when it comes to the endorsing peer, it's actually going to check whether the client who has sent the transaction for execution has the necessary permissions to do it. It will validate those certificates that the user has used to sign that transaction. Then it will execute the transaction, create the read-write set, then sign it with its certificate. And then when it goes to the next step, where it actually goes to the ordering service is also going to check whether the transactions that have been signed by the valid endorsing peer. So at each level, there are checks in place to ensure that there are no spurious identities being used anywhere in the transaction flow. So generally, this is how the identities get stored. You always have a key store, which is the private key, and then you have a sign-cert. And your backup, you can decide how do you want to back it up. As I said, you can do it in a hardware security module. And then also, when you're creating your network, you can also use TLS. The connectivity can be via TLS. So that also can be done. So that would be a specification in one of those configuration files that I was talking about. You will say that TLS enabled equal to true, which would mean that all the network connections that have been made will have transport layer security enabled. So You'll have your user identity is generally associated with who's actually going to use the client application as a user. Will only have permissions to actually just execute or invoke smart contracts, nothing more than that. Then you will have your admin identities. So generally admin identity is like any admin of a machine or a network. So they will have the identity, they will have the roles, permissions to actually create a channel or add your smart contracts, all those things. Then, as I said, since peer and orderers play a role in terms of during endorsement and during ordering, so they also have their own identity and they also have their certificates associated with it. Similarly, channels, again, channels, as I said, for each channel, you're going to have different admins in terms of who can install your smart contract on it, who can invite members, who can be part of the smart particular channel. So channel will also have their own identities, which will get stored. So you have to have all these identities. So generally, this is how it works. So whenever you write an application, so by default, I think when you create a network, admin is something that you create by default. And in one of those files, those network creation files, even the password is hard-coded. That is how it works. The admin password is hard-coded. And you can use that same password to actually use that admin and its password to actually download the certificates locally, which will get stored in the local MSP. And from there, you can actually enroll more users. So registration happens by default when you bring up a network. And then you download the certificates for that admin user. And with that admin user certificate, you can create more users, which you can use in your application. So as I said, that all transactions have to be signed at different stages and they get validated at different stages also. So your client application, when it sends for a transaction invocation, it will sign the proposal. The peer, which is your endorsing peer, is going to validate whether it's a valid user who has sent it, and then execute the read-write set, send it back. Again, you can validate a signature, you send it for order will validate again, then sign the block, and then send it back to the peer for committing, where it will get validated again. So checks and balances at each stage. And as I said, this is where you lose a lot of time. So another area of performance improvement is how you can improve this part. So that is why I think there's a lot of research or work happening in trying to use the hardware security module so that a lot of these certificate verification can be done by the hardware and not be done programmatically. Because at one transaction, it is okay, but when you want to scale up to maybe 1,000 transactions, you can imagine that at each step, you're losing time in all these validations. So I'm done for the day. And as part of next steps, that is for tomorrow, what I would want all of you, whoever have done the setup for the lab or whoever were able to install the Ubuntu image, can actually call a Git clone on this link so that it'll help you for the session that Shikha is going to run tomorrow. So I will go back to questions now. Just
please share this link on the chat.
Chat also, okay. Share. Oh, sorry, it did go. Sorry, selected. I think the meeting invite which I had. Let me just stop my screen sharing and then I'll copy it and put it.
The platform is open for the queries. Any queries?
Any queries? I think where did I last stop?
I can see one query. Can we close those repositories? Clone those repositories?
Yes, you can. You can clone those repositories. No issues.
Thank you, Ruchika. It
Thank
was
you.
a very well explained session. We hope, we fully trust that all the participants must have understood the basics of Hyperledger. And from tomorrow onwards, the hands-on on Hyperledger would be continued by Shikha and other members. Thank you, Ruchika, once again for joining.
Thank you. It was a pleasure.
Thank you, Ruchika. Thank you.
Thank you.
The session is closed. I think now the participants can leave. Is there any query? No. The session was so well explained that there are no queries.
No, I see something.
All the queries were handled in between. It was
Yes.